Hey everyone. So in this video we're going to finish up. We had, remember, one example on 6.3 we needed to do. And then, oh no, I lost my papers. 6.4. I will go find those notes in just a second. Okay, anyways. So this is the last example. I can't remember where we left off at. So I'm just going to say example. Okay, and we want to solve, oh, not 6, just example. I think it's example 6 in the book. But we want to solve 2x minus 5y equals 15 and 3x minus 6y equals 36 using matrices. So we're going to set up the matrix equation. So we have our coefficient matrix. So 2, negative 5, 3, negative 6. Our variable matrix, x and y, and our solution matrix, 15 and 36. Okay, so remember this is A, X, and B, and we talked about how X is equal to A inverse times B. So if we can figure out the inverse matrix of A and multiply it by B, then we get our solutions. Okay, and then right before the end of class on, let's see, today you were watching this on Friday, right? Yeah. Right before the end of the class on Wednesday, we talked about how there's a formula for finding the inverse of a 2 by 2 matrix. That's what I'm going to use for this example. So the formula is if you have a matrix, a 2 by 2 matrix that's column A, C, column B, D, then the inverse, so A inverse, if this is A inverse is 1 over, now it's technically called the determinant, but we don't know that yet. You will know that in a few minutes. But it's AD, so A times D, minus B times C, times, switch A and D. So this is D, and this is A. And then negate or change the sign on C and B. So negative C, negative B. So that's how we find the inverse. So I'm going to find the inverse of this one here. So 1 over A times D, 2 times negative 6 is negative 12, minus B times C, negative 5 times 13 is negative 15, times the matrix D times A, or excuse me, D times A. Switch A and D, so this is negative 6 and this is 2, and then negate B and C. So this is going to be 5 and negative 3. Okay, this right here is 1/3. So we're going to multiply 1/3 times all of this. So 1/3 times negative 6 is negative 2. 1/3 times 5 is 5/3. 1/3 times negative 3 is negative 1. 1/3 times 2 is 2/3. And that's our inverse matrix. Now we're going to take that inverse, negative 2, negative 1, 5/3, and 2/3, and multiply by the solution matrix, 15 and 36. Okay. This is 2 by 2. This is 2 by 1. So we're going to get a 2 by 1 out. Okay. So first row times first column, negative 2 times 15 is negative 30. 5/3 times 36, well 36 divided by 3 is 12, times 5 is 60. Obviously this is stuff you can do in your calculator, but we get 60. Second row times first column, negative 1 times 15 is negative 15. 2/3 times 36 is 24, so plus 24. So negative 30 plus 60 is 30. Negative 15 plus 24 is 9. That should equal our solution matrix, right? X, Y. Well, that means that X is equal to 30 and Y is equal to 9. Okay. All right. Now I'm just going to keep motoring along because there's no one here to ask questions, and you can pause the video. Okay. So now we're going on to 6.5. I'm not going to pause the video. Just give me a second. I left my notes right there. Sorry, 6.4. Uh-oh, the screen went black. Is it still trying? Yep, we're still going. Okay, 6.4. So 6.4, some vocab. We have the vocab determinant. So determinant is a scalar function. Remember, scalar is just a number assigned to a matrix. Now, this, in my opinion, is a terrible definition, but it's a definition from the book, and it's a definition for like a college algebra class that hasn't really talked about matrices a whole lot, or it's brand new. But this is a really bad definition. So a little bit more concrete definition, or where, like, what a determinant is this. It's how much a parallelepiped increases or decreases in volume. So a parallelepiped is any parallelogram of any dimension. So a regular parallelogram in 2 dimensions. Okay, a parallelogram in 3 dimensions, where you have a 2-dimensional parallelogram that goes through space. Okay, a parallelogram in 4 dimensions, which is a 3-dimensional parallelogram, kind of like this piece of paper, right? It has a really thin width, but that goes through 3D space. Okay, and what this determinant is it's, and obviously this is kind of advanced, but it's telling you how much the volume increases or decreases based on something called a linear transformation of this parallelepiped. Okay, you don't need to know any of that for the test. In my opinion, it's a little bit more concrete of a definition. Like, what's the point of the determinant? Like, what is that number? Because we're going to get a single number out, right? It's a scalar, so a single number. What's the point of that single number? And that's the point of it. Okay, it's not going to be used in this class. It's just taught in here. It's used in other classes. All right, so determinant is denoted by det of A, so determinant of A, or another way of writing it is absolute value of A. Okay, now it's not an absolute value. That's just how you're writing it. Okay, that's just the notation. Okay, but it doesn't mean absolute value. It means determinant when it's with the matrix. Okay, so the first thing we're going to do is there is a formula for finding the determinant of a 2x2 matrix. So determinant of a 2x2 matrix. If A equals the matrix column AC, column BD, then the determinant of A, which is equal to absolute value of A, determinant of A, is equal to AD minus BC, which is something we just did, right? So, looking at example here, example 1, let A equal column 6, 2, column negative 3, 3, and we want to find the determinant of A. Well, the determinant of A is AD, so 6 times 3, which is 6 times 3, minus BC, 2 times negative 3. 6 times 3 is 18, minus 2 times negative 3 is negative 6, so it's plus 6, which gives you 24, and that's your answer. Once again, it's just scalar, so it's just a number. This represents an increase in volume for some parallelogram, because it's a 2x2, okay, some parallelogram. Once again, you don't need to know it for the test, it's just that's what it represents. That's the point of this number. Okay, an increase in volume. All right. Now let's talk about, went black again. Okay, now let's talk about finding the determinant of any matrix. Okay, let's see here. First, we're going to talk about something called a minor. So the minor mi sub j, or m sub ij of the element aij, a sub ij, is the determinant of the matrix obtained by deleting the ith row and jth column. Okay, so to figure out a minor of a certain element, so like A11, so minor 1, 1, to figure out the minor of that element, you would delete that row and that column. So the first row and the first column in the matrix, and find the determinant of what's left over. And that's called the minor. Cofactor. The cofactor, A sub ij of little a sub ij, is a sub ij, capital A sub ij, equals -1 to the I plus j power times the minor of I sub j. Okay. Let's do, okay, moving on. I promise you we'll go over examples of these. Okay. Okay, now the determinant of a square matrix. Notice we can only find determinants of a square matrix. So the determinant of A, which is absolute value of A. Now I'm going to draw a matrix, an n by n matrix. So here we have A11, A21, all the way down to AN1. This is A12, all the way to A1n. And this is A22, all the way down to AN2. But this is all the way over to A2n. All right, and then these continue until we get ANN, and there's stuff in between also. So the determinant of that matrix is equal to A11, so first element, times the cofactor A11, plus A12 times the cofactor of A12, plus element or entry A13 times the cofactor A13, plus all the way up, plus entry A1n times element, or sorry, entry A1n times cofactor A1n. Okay. So essentially what it is, take all of the entries in your first row, multiply those entries by the cofactor of those entries. Okay. Now, technically, you can use any row you want, but for now, in my opinion, because this is the first time you've ever seen it, I would just stick with the first row. There might be, you might have a little extra work, because if you have a row that has zeros, then when you multiply by 0, it cancels things out, and so that's nice. But since this is your first time using this, ever seeing it, I would just stick with the first row, so you're not confused on, which row should I use? If you ever take a linear algebra class and you start working with matrices more and then become more familiar, then I would say go ahead and move rows around. But for now, in class, I'm always just going to use the first row. Because once again, it's brand new stuff. And if we just stick with the first row, there's less things there's other things more important things we can focus on. All right. Let's do an example. Oh, actually, sorry. There's one other thing. Signs of the cofactors. So remember, a cofactor, a sub ij, is equal to -1 to the I plus j power times the minor sub ij. Well, I can make a matrix. I'm going to keep this up here too. This -1, if I'm at entry 1, 1, so I is 1 and j is 1, this is -1 to the 1 plus 1 power, which is 2. -1 squared is +1. It's a positive 1. If I'm at entry 1, 2, then this is 1 plus 2, which is 3. This is -1 to the 3rd power, which ends up being a -1. If I'm at entry 1, 3, then this is 1 plus 3, which is 4. -1 to the 4th power is +1. So this is a positive. If I'm at entry 2, 1, then this is 2 plus 1, which is 3. -1 to the 3rd is negative. So we actually get this kind of checkerboard pattern. And if you remember that checkerboard pattern, then you don't have to remember this bit of the cofactor. All you got to do is find the minor. So this bit of the cofactor is taken care of there. Okay, and that's what I'm going to end up using when finding determinants. Okay, and you'll see with the example. Okay. Let's see here. So I'm going to erase this. Okay, example 2. Find the determinant of A if A equals 2, 0, -2, 3, 2, 5, -1, 4, 6. Okay. So remember, the determinant of A equals entry 1, 1, so little a 1, 1, cofactor 1, 1, plus entry 1, 2, little a 1, 2, times cofactor 1, 2, plus entry 1, 3, cofactor 1, 3. Now I only have to go to here because there's only three elements in row 1. So the 3 elements. Okay. Now, instead of using a1, 1, I can use the minors and then just use this as the cofactor part. So this first one, a11, is in this first spot, so it's going to be positive. So a11, m11, minor. This next spot is a negative, so instead of writing a positive here, I'm going to write a minus. a12, m12. The minor. Remember, the cofactor, the only thing different between a minor and a cofactor is the cofactor has that -1 to the I plus j power. That -1 to the I plus j power is taken care of here. Right? It just tells me when to switch signs. So if I switch the signs, then I can use the minors. And then, so this a13 is positive, so it's going to stay positive. And then we have minor. Okay. So let's look at the entry a11. That's a 2. So we have 2 times the minor 1, 1. So if you look back at your definition of minor, to find the minor, it's the determinant of the matrix that's created by deleting row 1, column 1. So if I delete row 1 and column 1, we're left with 2, 5, 4, 6. 2, 5, 4, 6. So it's 2 times the determinant of that matrix. Minus A12 is 3 times the determinant. The minor of 1, 2, of element 1, 2, is you delete the first row and second column. So 0, -2, and 4, 6. 0, -2, 4, 6. Then a plus sign. Element A13 is -1 times the determinant. Minor 1, 3 is delete the first row, third column. Deleting the first row, third column leaves us with 0, -2, 2, 5. 0, -2, 2, 5. Okay. Now we want to find the determinants of those three matrices. But that's a 2 by 2. We have the formula. AD minus BC. So 2 times AD, 2 times 6 is 12. Minus BC, 4 times 5 is 20. Minus 3 times 0 times 6 is 0. 4 times -2 is -8. So minus a minus 8 is plus 8. -1 times 0 times 5 is 0. Minus 2 times -2 is -4. A minus minus 4 is positive 4. So then we have 2 times 12 minus 20 is -8. Minus 3 times 0 plus 8 is 8. Minus 1 times 0 plus 4 is 4. 2 times -8 is -16. -3 times 8 is -24. -1 times 4 is -4. Add all these up, we get negative, what is it, 44? Is that? Yeah, -44. So -44 is the determinant of this matrix. Okay. Obviously I went through that fast. That's why, but you guys can pause. Okay, you can pause. All right. Now another definition. Oh, I need to leave that up. Plus, minus, plus, minus, plus, minus, plus, minus, plus. Invertibility. Criterion. If A is a square matrix, then A has an inverse if and only if the determinant of A is not 0. Okay, so if A is a matrix and we find its determinant, and its determinant is not 0, then we know it has an inverse. If the determinant equals 0, then we know it doesn't have an inverse. Okay, you can look back at your notes on the last section, 6.3, when we're finding inverses. There was one of the examples, I think it was example 4 or 5. It didn't have an inverse. If you find the determinant of that matrix, it should equal 0. All right, so example 3. Prove that A equals matrix column 1, 3, -2, 2, -1, 3, 0, 2, -2 has no inverse. Okay, well, we need to find the determinant of A, which is the absolute value of A, which is A11, right? Entry 11 times cofactor 11 plus entry 12 times cofactor 12 plus entry 13 times cofactor 13. But we know the cofactors just change the signs from the minors, so we can just substitute these signs. So positive goes here, A11 minor 1, 1. And then the next one's going to be a negative, so we switch this to a minus. A12 minor 1, 2. The next one's a positive, so we keep this one a positive. A13 minor 1, 3. Okay. Element 1, 1 is a 1. Okay. Times the minor 1, 1. So minor 1, 1, you eliminate first row, first column. The matrix that's left over, negative 1, 3, 2, negative 2. Negative 1, 3, 2, negative 2. Minus A12. So entry 1, 2. So a 2 times the minor, the determinant of the matrix. Oh, sorry, this is 1, 2. The matrix, the determinant of the matrix when you eliminate first row, second column. So eliminate first row, second column, and you got 3, negative 2, 2, negative 2. 3, negative 2, 2, negative 2. And then plus third element, 0, times the matrix, or the determinant of the matrix when you eliminate the first row, right? Minor 1, 3, eliminate the first row, third column. So 3, negative 2, negative 1, 3. 3, negative 2, negative 1, 3. Okay, now let's find those determinants. Now, right off the bat, this is 0 times anything, right? Is 0, so this cancels. Don't even got to worry about it. So now let's look at this one. 1 times anything itself, so we don't got to worry about the 1. Now find the determinant. A times D, negative 1 times negative 2 is 2. Minus B times C, 2 times 3 is 6. Minus 2 times the determinant of the second one. A times D, negative 6. Minus 2 times negative 2, which is negative 4. So minus and minus 4 is plus 4. Equals 2 minus 6 is negative 4. Minus 2 times negative 6 plus 4 is negative 2. Negative 4. Negative 2 times negative 2 is positive 4. Negative 4 plus 4 is 0. We got a determinant of 0. By the invertibility criterion, this has no inverse. Okay, remember, if the determinant is 0, no inverse. Okay, last thing here. Okay, and we have 2 more examples. Cramer's rule. Cramer's rule is very important. It's a very important thing to know from this class for chapter 6. Hint, hint. Cramer's rule. For a linear system, it has the solutions x equals, now technically this works for any number of solutions. We're only going to go up to a 3 by 3, so I'm just going to give you x, y, and z. Okay? X equals the determinant of a matrix sub x, and I will tell you what that means in a second, over the determinant of the matrix. Y equals the determinant of d sub y over the determinant of d. And z equals the determinant of sub z over the determinant. Where d sub x is the matrix where the first column is replaced with the solution matrix. Okay, so we have a matrix D. Okay, matrix D. The matrix D sub x is I take the x column of the original matrix and replace it with the solution column. D sub y is you take the original matrix and replace the y column with the solutions. D sub z is you take the third column or the z column and replace it with the solutions, and then find the determinants. Okay. All right, let's do an example of this. Example 4. So this first example is a 2 by 2, and then we'll do a 3 by 3, which is a lot of work, but we'll do it. Okay. So use Cramer's rule. To solve 2x plus 6y equals -1, and x plus 8y equals 2. All right. So let's make our solution, or our matrix equation. So the coefficient matrix is 2, 6, 1, 8. Okay. And then our variable matrix is x, y, and that equals the solution matrix, which is -1, 2. So this is A, X, B. Okay. Or let's call this matrix D, because that's how our definition was done. Okay. So this is matrix D. Let's figure out matrix D sub x. Well, matrix D sub x is you take the x column and you replace it with the solutions. So instead of 2, 1, it's going to be -1, 2, but the y's stay the same. So 6, 8. Let's figure out D sub y. So D sub y is you take the y column and replace it with the solutions. So we'll still have 2, 1, but instead of 6, 8, we're going to have -1, 2. Okay, and then, like I said, this is just regular D. Okay. Now, to figure out what x equals, we take the determinant of D sub x and divide it by the determinant of D. And y is equal to the determinant of D sub y over the determinant of D. So we've got to figure this stuff out. Let's figure out the determinant of D. Okay, so this is a 2 by 2. So the determinant of D is AD, right? Little a, little d. So 2 times 8, which is 16, minus 1 times 6, which is 6. So it gives us 10. Now we need to figure out the determinant of D sub x. -1 times 8 is -8, minus 6 times 2, which is 12. And that gives us -20. And then the determinant of D sub y, 2 times 2 is 4, minus -1 times 1 is -1, which gives us 5. So now we plug and chug. The determinant of D sub x is -20 over the determinant of D, which is 10. -20 divided by 10 is -2, and that's what x equals. The determinant of D sub y is 5. The determinant of D is 10. 5 over 10 is 1/2. That's what y equals. And we're done. Okay, that's the solution. Those are the solutions to this system. Okay. All right, one last one here. A 3 by 3 using Cramer's rule. Alrighty. Use Cramer's rule. Sorry, this is example 5. To solve, and here's our system. 2x minus 3y plus 4z equals 1. X plus 6z equals 0. 3x minus 2y equals 5. So we got to figure out what the matrix D is. Remember, matrix D is the coefficient matrix. So that's 2, -3, 4, 1, 0, 6, 3, negative 2, 0. Okay, that's the solution matrix. Can you guys see that? Oh, there's a glare. Oh no. I just realized there's a glare. You see it now? Okay, that's better. That's D. Now let's find the absolute value of D, or the determinant of D. Sorry, not absolute value. I don't know why I keep saying that. Determinant of D. Well, entry 1, 1 is 2 times, remove first row, first column, you get 0, negative 2, 6, 0, minus negative 3 times the determinant, remove first row, second column, 1, 3, 6, 0, plus next term or next element, 4 times the determinant, remove first row, third column, 1, 3, 0, negative 2. This is 2 times 0 plus 12. All right, we're just finding the determinant of a 2 by 2. We've done this a few times now, so I'm going to go through it kind of quickly. Negative and negative is a positive, and this is 0 minus 18, and plus 4 times negative 2 plus 0. So we get 24 minus 54 minus 8, and that gives us negative 38. Okay, so that's D. D sub x. Remove the x column and put in the solutions, 105. So 105, negative 302, 460. Determinant of D sub x, that's 1 times, remove first row, first column, 0, 6, 2, 0, minus negative 3, remove first row, second column, 0, 5, 6, 0, plus 4, remove first row, third column, 0, 5, 0, 2. 1 times anything is itself, so we don't have to worry about that. 0 times 0 is 0, minus 6 times 2 is 12, plus 3 times 0 times 0 is 0, minus 6 times 5 is 30, plus 4 times 0 times 2 is 0, plus 0 times 5 is 0. This cancels, right? 4 times 0 is 0. 0 minus 12 is negative 12. 0 minus 30 is negative 30 times 3 is negative 90. So we get negative 102. Did I do that right? Oh, this is a negative 2. This is a negative 2. Makes this a positive 12. That's a positive 12. Which makes this negative 78. Okay, D sub y, remove the y column in your D matrix and plug in the solutions. So we have 2, 1, 3, 1, 0, 5, 4, 6, 0. Find the determinant. So it's 2 times matrix 0, 5, 6, 0, minus 1 times matrix 1, 3, 6, 0, plus 4 times determinant of matrix 1, 3, 0, 5. So this is 2 times 0 minus 30 minus 0 minus 18 plus 4 times 5 minus 0. Negative 30 times 2 is negative 60. negative 18 times negative 1 is positive 18. 4 times 5 is 20. And we get negative 22. And then d sub z, we take our D column, or our D matrix, replace the Z column with the solutions, 1, 0, 5. So we have 2, 1, 3, negative 3, 0, 2, negative 2, and then 1, 0, 5. Find the determinant. So we have 2 times 0, negative 2, 0, 5, minus a negative 3 times 1, 3, 0, 5, plus 1 times 1, 3, 0, negative 2. So then this is 2 times 0 plus 0, which cancels. This is 3 times 5 minus 0, and this is the 1 cancels because 1 times anything is itself. So plus negative 2 minus 0. 3 times 5 is 15, minus 2 gives us 13. Okay, so then x, let's see, where do I have space at? I'm going to put it in a different color here. X equals determinant of dx over determinant of d, which is negative 78 over negative 38, which simplifies to 39 over 19. Y equals determinant of d sub y over determinant of d, which is negative 22 over negative 38, which equals positive 11 over 19. And z equals determinant of d sub z over determinant of d, which is 13 over negative 38, which is just negative 13 over 38. And those are your solutions. Okay. I know it's a lot, but if you just remember, you're finding determinants 1, 2, 3, 4 times. That's all you're doing. Finding the determinant 4 times and then dividing them. Okay. Like I said, oh my goodness. Like I said, super important thing for this chapter, hint, hint. Okay. Reminder, chapters or homework 6.1 and 6.2 are due on Tuesday. 6.3 and 6.4 are due on Thursday. The test is on Thursday. We will review on Tuesday. If you want, we can go over this stuff more. We can go over other things. It's the entire day. We have 4 sections, and for the test, right? There's only 4 sections, so we can spend time pretty much reviewing everything.